All right, so now we're going to go ahead and divide. So if you remember when you're dividing with fractions, what you need to do is you need to multiply by their reciprocal. But every other aspect of dividing fractions is the same as multiplying. So the same thing is going to apply now that we're dealing with polynomials. So the first thing you're going to factor is just like we did before. Then you're going to multiply by the reciprocal. So when you multiply by the reciprocal, then you pick up with the multiplication steps of squishing them all together and then canceling anything out that is in common. So we're going to go ahead and do these first two examples. So the first thing I'm going to notice is that here in example A, these are monomials. So you cannot factor. So we don't need to worry about doing any of those. So we're going to go ahead and just jump to multiplying by the reciprocal. So before I do anything, I'm going to just rewrite my first term. So remember when you're multiplying polynomials, when you're dividing polynomials, you only flip the second one, whatever you're dividing by, whatever comes after the division sign. Even if you think it's more convenient to multiply the first one, you can't do that. So once we're at this point, now we have a multiplication problem. This is exactly what we just did. Multiply on top, so 5 times 8 is going to be 40. X to the 4th and y to the 5th, you can't combine them because they have different bases. 8 times 15 will be 120, and then x squared, y squared. So go ahead and finish that off by simplifying your fraction. 40 over 120 is going to simplify to be 1/3. And then x to the 4th over x squared will become x squared, and y to the 5th over y squared will become y cubed. So you can leave that 1 there if you want. You can have 1/3 with it next to it, or if you want to just write x squared y cubed over 3, that could be your final answer. Now when we look at B here, we've got these 4 different pieces, and we're going to have to flip this. But in the directions we say factor first. So I'm going to go ahead and do that. I'm going to factor it exactly like it is. I'm going to factor this GCF out of this top numerator here. So we'll have x times x minus 2. I can't do anything with a 5x. I have a GCF that I can factor out of 3x minus 12, so I can take that 3 out and have x minus 4. And then numbers that multiply to be a positive 8 and add up to be negative 6 would be an x minus 4 and an x minus 2. So now what I'm thinking about is this fraction, 5x over 3 times x minus 4 divided by the x times x minus 2 over x minus 4 times x minus 2. So now I'm going to go ahead and flip them because I'm multiplying by the reciprocal. So I'm changing this now to multiplication, and I'm taking the denominator, x minus 4, x minus 2, and making it on top of the numerator, and putting x and x minus 2 on the bottom. So now I've multiplied by the reciprocal, I've flipped it, now I can multiply, I can squish everything together. So 5x times x minus 4 times x minus 2 over 3. I'm going to go ahead and take this x right here and just move it out front because that just makes a little bit more sense when we write it. And then x minus 4, x minus 2. So you can see when we're looking for common factors, these x's are the same thing. So those can cancel out. The 5 is separate from the x. The 5 of it is its own thing. So the x's will cancel, the x minus 4's will cancel, the x minus 2's will cancel, and we'll be left with 5 over 3. Alright, so now we've got some polynomials with x to the 4th, so just take it step by step. I'm going to look here, I'm going to take out an x squared, and I'm going to be left with an x squared minus 9. Then I'm going to realize that x squared minus 9, I can actually factor that a little bit more. So I still have that x squared, but now that x squared minus 9 is the difference of squares and becomes x plus 3 and x minus 3. Don't mess up factoring, you'll screw up your whole problem. And then this one down here, numbers that multiply to be positive 3 and add up to negative 4, that's going to be x minus 3 and x minus 1. Over here, I can take out an x squared again. So now I have x squared plus 2x minus 8, which I can notice I can factor that trinomial again. So we still have the x squared, but now numbers that multiply to be a negative 8 and add up to be a positive 2 are going to be x plus 4 and x minus 2. So we're factoring everything 100% completely before we do anything else. And then down here, x squared minus 16 is another difference of squares. Becomes x minus 4 and x plus 4. So now I'm going to go ahead and do my multiplication. So I'm going to rewrite my first term here exactly how it is, 100% factored, with x squared times x plus 3, x minus 3, all over x minus 3 and x minus 1. And now I'm changing this division sign right here. I'm changing that to multiplication, and I'm going to go ahead and flip these. So I'm going to have now x minus 4, x plus 4 on top, and I'm going to have x squared, and x plus 4, and x minus 2 on the bottom. So now I've changed this into a multiplication problem, so I can go ahead and squish everything together. I'm going to go ahead and move any coefficients or monomials out to the front. So I'm going to go up here now. X squared times x plus 3 times x minus 3 times x plus 4 times x minus 4, all on top. I've got x squared on the bottom, x minus 3, x minus 1, x plus 4, and x minus 2. So if you want to cancel over here in this step, that's fine. I'm just trying to do 100% steps here, not trying to skip anything. So now I'm going to match up things that can cancel. So x squared over x squared, those are identical. If I had x cubed over x squared, I could simplify that still to just be x, but since these are the same, they'll both cancel out. X plus 3, I don't have any x plus 3s that'll cancel out, but I do have an x minus 3 that'll cancel out. I do have an x plus 4 that will cancel out, and then this x minus 4 is going to stay. So all 4 of these pieces that are underlined are going to go ahead and stay as my final answer. X plus 3, x minus 4, all over x minus 1, and x minus 2. So that's going to be my answer. Do not FOIL, okay? It's a way that you're going to make a lot more mistakes, and it's unnecessary. It's not going to do anything for you for your problem. Alright, so as we look at this problem, you notice that we're dividing by 2x squared plus 3x. We're just dividing by one term, we're not dividing by a fraction. So before we get started, I'm going to go ahead and put this over 1 so that I don't forget and I don't screw up when I'm trying to multiply by the reciprocal. So now I'm going to go ahead and factor, and notice that now I have a leading coefficient of 6, so I'm going to have to think about factoring this. I'm going to think about numbers that multiply to be negative 18 and add up to be 7. So those magic numbers are going to be 9 and negative 2. So as we think about factoring that, I might need a little more space, so I'll do right here. 6x squared plus 9x minus 2x minus 3. We're grouping here, so we'll take out that GCF of 3x. We're left with 2x plus 3. Take out that negative 1. We're left with 2x plus 3. So now I've just factored this into 3x minus 1 and 2x plus 3. And it's all over 6x squared. And then that's being divided by this 2x squared plus 3x. So if I go ahead and factor that, I can take out an x, and I'm left with a 2x plus 3. So I'm going to go ahead and change this to multiplication now. This is my first term here. These are matching. I've just done the factoring. And now I'm changing division into multiplication, and I'm going to go ahead and flip these two. So now I'm going to have 1 over x times 2x plus 3. I keep forgetting those parentheses. So now when I do my multiplication, when I squish it all together, 3x minus 1 times 2x plus 3 with the 1, we don't need to write that down, and then 6x squared, keep that monomial out front, and then another x and a 2x plus 3. So if you kind of see like this x squared and that x, that's going to combine together to become x cubed. Then we can also see that we have something that's going to cancel out. We have this common factor of 2x plus 3 on top and on bottom. So now I'm going to be left with 3x minus 1 over 6x cubed. Now that's going to be my final answer. A lot of you are going to be tempted to want to cancel this 3 and this 6, but you can't because the 3x minus 1 is a group together. If it was 3 times x minus 1 over 6, then you can. But because there's no parentheses, you have to leave it like this.